helpful if I showed you the homework for today. So I am using an app called Notability, and how I'm going to use it is I'm going to go to my drive. I'll kind of do it from the start. So I'll go to, first I saved the file to my Google Drive. Then I would find the file in my Google Drive and go to my dots here and send a copy of the file to Notability. So I had to have that app installed in order for that to pop up. And so I sent a file to the Notability app, and it'll say, do you want me to create a new note? Which I do. And then I can import my file to Notability. Once I've done that, if I open my Notability app, oops, I'll show you again. So if I open my Notability app, there it is, right? I might have to click it and open it, but there is the worksheet for today. And I can pick a pencil. I've already kind of picked this purple color and that thickness, and that's it. And so now, if I just zoom in, I can start my work. So it says list the perfect squares from 1 to 225. So 1 is a perfect square, 4 is a perfect square. Yikes, that's a little bit thick there. So I'm gonna come down to a thinner one. 1 is a perfect square, 4 is a perfect square, that's better. 9, 16, 25, can scroll it over. 36, 49. 6 times 6, 7 times 7, 8 times 8, of course, is 64. 9 times 9, 81. Oops, 81. And then 100, 121, 144. You don't have to have these memorized. So on the quiz, it'll just ask you for 12 times 12. It'll ask you to like name 4 perfect squares or something like that. Or maybe name the perfect squares up to 100. We wouldn't have you go all the way to 225, but those are the perfect squares up to 225. Is this number a perfect square? Yes or no? So is 9 a perfect square? Why, yes it is, because the square root of 9 is 3. Is 20 a perfect square? No, it is not. We don't know the square root of 20. It would be a decimal, so it's not a perfect square. Same thing with the square root of 50 is not a perfect square, but of course the square root of 4 is 2, so yes, that's a perfect square. Then this is talking about the difference between squaring and square rooting, right? Square root of 4 versus 4 squared. The square root of 4 is 2 versus 4 squared is 16. If we write it out in words, it says the square root of 16, that's 4, right? 11 squared is 11 times 11, which is 121. And the exact square root of 8, that's tricky. People think it's a decimal, but when we do exact square root, that's when we're actually simplifying the square root, like we learned in the start of the chapter. So the exact square root of 8 is 2 root 2. People often get confused on these questions, and there's one on the quiz. So the square root of 23 is between which 2 consecutive whole numbers? So that means which 2 regular numbers, right? So the square root of 25 is 5, and the square root of 16 is 4. And so since 23 is between 16 and 25, the square root of 23 is between 4 and 5, right? Because the square root of 16 is 4, and the square root of 25 is 5, right? Square root of 67, you would think like, okay, square root of 67, what 2 perfect squares is that in between? I can even go up to my list, like, oh, 67 is between 64 and 81, so the square root of 64 is 8, and the square root of 81 is 9. Another way to do that is you could also look on your calculator and say square root of 51, and it's going to be 7 point something, and that decimal is between 7 and 8. Here we're not going to use any calculator, no decimal answers. We're simplifying each square root. So you're separating it into one you can do and one you can't do. So I can do the square root of 4 is 2, but I don't know the square root of 5. So it's 2 root 5. The square root of 45 is the square root of 9 times the square root of 5. And you'd want to show this work. The square root of 9 is 3, and the square root of 5, I don't know. So I'm simplifying each square root. Square root of 48, some people think 8 times 6 or 4 times 12. We've done this a few times. The better way to go is to do square root of 16, square root of 3. The square root of 16 is 4, so it's 4 root 3. Kind of messed up the circle. Square root of 600 is the square root of 100 times the square root of 6. The square root of 100 is 10 root 6. There. Now they start getting, a little bit trickier, like maybe putting a number in front. 7 root 18. The square root of 18 is the square root of 9 times the square root of 2. The square root of 9 is 3. 7 times 3 is 21. For 10 root 12, the square root of 12 is root 4 root 3. The square root of 4 is 2. And 10 times 2 is 20 root 3. That's a 3. Coming over here to 7 root 75, the square root of 75 is root 25 root 3. And the square root of 25, of course, is 5. Oops, that has a root still. So it's going to be 35 root 3. Again, I'm making my 3's all weird for some reason. Here we're going to multiply it together, then take it apart. Since they're both under square roots, square root 5 times square root of 10 is square root of 50. And then that can be reduced square root of 25, square root of 2, 5 root 2. Last row here, another multiply it together and then take it apart. Square root of 12, square root of 2 is square root of 24, which would reduce to 2 root 6. Let's see, here I've got outside numbers and inside numbers, so I'm going to multiply together. 9 times 4 is 36. Square root of 5 times square root of 20 is square root of 100, which I'm lucky is a perfect square, so it's just 36 times 10, or 360. Scooching over here, 5 root 10 times 3 root 2 would be 15 root 20. Square root of 20, of course, square root 4, square root 5. The square root of 4 is 2, and 15 times 2, final answer is 30 root 5. 30 root 5. We see one like 23 a lot, and the key to this one is to write it 2 times. To square something is to multiply it by itself, so it's going to be 36 root 49, or 36 times 7. Doing that in my head real quick, 252. 252. Okay, so here we only use a calculator when it says use a calculator. So now it says use a calculator, and you see that squiggly equal, right? So I'm gonna grab my calculator here, sorry. So if I use my calculator, I'm just gonna type in square root of 11, enter 3.316. I always round to 2 places after the decimal, so the 6 gives the 1 a shove, and so my final answer here is 3.32. And the rounding correctly is part of the credit. Now here I have a little star by the square root of 26, so a little star usually means something. I'm looking at this 5.099, that 9 rounds that 9 to a 10. So it's either going to be 5.10, or you could have said 5.1. If you have a number in front, like 6 root 2, no biggie. You just type it in your calculator. 6 root 2 is going to be 8.49. 8.49. And then this one here, square root of 4/5, square root of 4 divided by 5. And I don't even have to close the parentheses. The calculator knows it would be 0.89. So square root of 4/5 is 0.89. Perfect. Okay, so now we transitioned to Pythagorean Theorem, which we have always known. The Pythagorean Theorem, a squared plus b squared equals c squared. I always ask what type of triangle. It's always used on a right triangle, that's an R, right triangle. So the first one say like, could this be a right triangle, right? And this one's in order, and you have to write a little equation. Does 4 squared plus 7 squared equal 9 squared? And it's a question, right? Does 16 plus 49, does that equal 81? No, it does not. Here, they're a little bit out of order, so I got to make sure I write the C last. Does 10 squared plus 24 squared, does that equal 26 squared? And that one's actually a yes. You might recognize that as one of our Pythagorean triples we've seen. I don't think the next one works. I don't know, maybe it does. 12 squared plus 16 squared, does that equal 20 squared? So 144 plus 16 squared, does that equal 20 squared? Yes, it actually does. Yes, it equals 400. I'm just showing that on my calculator. And then here, does 20 squared plus 21 squared, does that equal 28 squared? So again, I'm just typing this in. Does 20 squared plus 21 squared, does that equal 28 squared? No, so that's a no. Now we actually start doing some Pythagorean theorem questions, right? And we know that the key there is that you get the C correct, right? So let's see, zooming it in here. So the equation here would be 3 squared plus 6 squared equals x squared, or 9 plus 36 equals x squared. So you'll notice here I'm asking for two types of answers, exact and approximate. So when we take the square root of 45, for the exact answer, we're simplifying it square root of 9, square root of 5, or 3 root 5. That's the exact answer. The approximate answer comes from the calculator, typing it in 6.71. And you see again that squiggly equal. The exact answer, the approximate answer. Starting with 34, now this one's a little bit trickier. 3 squared plus x squared equals the 3 root 2 squared. And by the way, this works a lot better if you have a stylus. We don't. So yeah. So 3 root 2 squared, I could do that on my calculator. That's possible. I have to just do that double parentheses squared, or I could do 3 root 2 times 3 root 2, and I'm going to get 18. So when you subtract 9 from both sides, it equals 9, and then this is kind of good news. There's only an exact answer. Why can't I write a 3 right? It's just a 3. And if you recognize this, this is one of our special triangles. Do you recognize that? 3, 3, 3 root 2, that's a 45, 45, 90 triangle. You might now recognize the next one. I don't know, we'll see. 1 squared plus x squared equals 2 squared. Nice and low numbers here, plus x squared equals 4, so x squared equals, that was an equals 3, square root, square root. So the exact answer is just square root of 3. And if I do that on my calculator, square root of 3 was 1.73. Now that one you might recognize, now that you see the pattern, x, 2x, x root 3, this is actually a 30, 60, 90 triangle. So unknown to you at the time, we were actually giving you our special triangles back then. Two more like little story problems. You do have a story problem on your quiz. A 20-foot ladder is leaning against the wall. It reaches up the wall. 16 is the wall, and then there's the x. So the equation is x squared plus 16 squared equals 20 squared. So x squared plus, that's 256, and that's 400, that's an equals. So I'm going to subtract 400 over here, minus 256, and then I'm so thankful because the square root of 144 is 12. So the final answer there is 12 feet, I should say, 12 feet. Now you might, like in this one, I'm going to show the work, but I might recognize that as 45, 45, 90, right? Because you see the 2 8s, but it's good to show the work because it's kind of showing why it's 8 root 2. 8 squared is 64 plus 64 here, I gotta zoom in more, is 128 equals x squared. So if I square root 128, square root of 64, square root of 2, or 8 root 2. So just like we thought from the pattern, x root 2, it does turn out to be 8 root 2. Okay, so now we have our special triangles, 45, 45, 90. So 45, 45, 90. Come on. So let's see. It's going to be trouble just getting down. Let's just try it from there. So the legs of a 45, 45, 90 are always equal. And the hypotenuse is root 2 times the leg length. And then these are, I'm just going to circle it, isosceles triangles. They're actually isosceles right triangles. So I'm going to write that both. It's a right isosceles triangle. And then for the 30, 60, 90, there's a little bit more, right? So it's x, 2x, x root 3. So it's x, 2x, x root 3. So the shortest side is across from the 30, of course, the smallest angle. The longest side is across from the biggest angle, the 90. The hypotenuse is double the short side. And the side across from the 60 is square root of 3 times the shortest side. So it's a little trickier because these are scalene right triangles. So it still is the right angle, but all three sides are different. Now you could always go back to Pythagorean Theorem and prove these, but the idea is that you kind of notice like, hey, these two sides are equal, so x is going to be 5, 5, 5, 5 root 2. I like to write it on the picture as well as the answer blank. 5, 5, 5 root 2. Another kind of basic one would be number 39 here. It's going to be 3, 3, 3 root 2, right? These two sides are the same, and 3 root 2. The two legs are the equal sides, and the hypotenuse is the one that gets multiplied by the square root of 2. Gets a little harder with 45. This is root 11, root 11, root 11, root 2. You might recognize these are some of the same questions we had on our other worksheet. Root 11, those two sides are equal. Root 11, root 2 just simplifies to root 22. Similarly with number 41 here, it's root 7 for the x, and then root 7, root 2, or root 14 for the y. I guess I have another row of 45, 45, 90s. Yeah, this one's where this row here, they gave you the hypotenuse. So if the hypotenuse is 16 root 2, those two sides are 16. If the hypotenuse is 11 root 2, these two sides are 11. 44, if it's 2 root 2, then these two sides are 2. And then this is only the hard one. It's root 10. So you got to think about it like, what would multiply times root 2 and give you root 10? So that one's root 5 for each of them, because root 10 is really root 5, root 2. So I'm going to put a star by that one. That one's a little harder. Root 5, root 5. Last special triangles, the 30, 60, 90. Now this one can be given different things. So I think I did a row for each one. So in the first row here, they're giving us the hypotenuse. So I'm going to cut the hypotenuse in half to get the side opposite the 30, and then multiply that by root 3 to get the side opposite the 60. Same thing here. The hypotenuse is the 8. I cut that in half, 4 for the x, and then 4 root 3 for the side opposite the 60. Similarly, 14, you just got to kind of orient yourself, like which is the side opposite the 30, which is the side opposite the 60. And then the last one here, 12 is the hypotenuse, so it's 6 and 6 root 3. So it was like 4 that were pretty much exactly the same. The next row I gave you the side opposite the 30 is 11, so I'm going to double that to 22 for the side opposite the 90, the hypotenuse, and then 11 root 3 for the side opposite the 60. Here the 5 doubles to 10, and then 5 root 3 for the y. Here the 10 doubles to 20. I got to be careful though, that's actually the y in that case is the 20, and the 10 root 3. Sorry, it's shaky. And then the last one, that looks like it's kind of cut off there, but it looks like 3 root 3. So that one I'm going to double to 6 root 3 for the hypotenuse. Oops. Okay. Yeah, 6 root 3 for the hypotenuse. It's not fitting in. 6 root 3. Okay, I get you. You don't want me to write it. Okay, fine. 6 root 3. And this one's harder than what we would have on a quiz or a test anyway. And then this would be 3 root 3 root 3, which is 3 times 3, which is 9. That's like over our heads maybe. So you don't have to worry about one like 53. Finally, the last row, now they're giving me the side opposite the 60. Basically, all I do to get the side opposite the 30 is to take the root 3 away and then double to get the side opposite the 90. And you got to pay attention like which one's the x, which one's the y. So here the x is 8, the y is 16. Let's see, come on. Last couple here, 18 root 3, so the x is going to be 18 and the y is going to be 36. And then the very last one, let's see, the x, oh, that's the hypotenuse, is 20. So the x is 10 and then 10 root 3. So I know that took a little bit of time, but I thought it would be helpful for you to see the whole worksheet.